Hey guys, what's up? This is ETSK Tutorials, and this is FPS 1.6. If you've noticed, when you walk around in the game right now, things just feel straight up slippery. It feels like you're running on ice. It's really unrealistic, and it just feels like you're running on ice because we don't have any friction applied to our player yet. So we're going to put some code into place to make it feel a little bit more realistic. So basically, we're only going to be using one variable today, so that should be refreshingly simple. So we have var walk deacceleration, and this is going to be a float. And basically, the larger this number, the faster we're going to deaccelerate when you let go of the WASD and you're not moving. So this is going to make it a lot more realistic, and when you let go of WASD, you're just going to not just stop, but you're going to slow down more quickly, and we'll be able to adjust walk deacceleration to make the most realistic slow down motion so that it feels more real and so you don't slide all around the place. So it should feel a lot more realistic and a lot better after we apply this variable. So today we're only going to be working with one real snippet of code that we're going to be putting inside of the update loop for the player movement script. So basically what this is saying is that if A and D are not pressed and W and S are not pressed and we are touching the ground, divide the rigid body.velocity.x by walk deacceleration and divide the velocity.z by walk deacceleration. So let's go over that in more detail. So if input.getAxis horizontal equals 0. So we're accessing input, get access, horizontal. So depending on whether you're using a controller or WASD, if A and D are not pressed or you have the controller just let alone and just set in the middle, then it'll return 0. And we have two equal signs right here because in Java, if one equal sign means that you're changing a variable to something else. So in Unity, we have an if statement, and we're testing whether or not it is equal to 0, so we gotta put two equal signs right next to each other. And then we have the two and symbols, which means ands. Input.getAccess vertical equals 0, and grounded. So pretty simple. If all the W, A, and D are not pressed and we're grounded, this whole statement's going to return true, and then inside of this opening bracket and closing bracket, it'll execute these two lines of code. And those two lines of code are rigidbody.velocity.x, divide equals, so this is just like plus equals or times equals, but with a division symbol or a forward slash. It's going to divide it by walk deacceleration. So that's going to give us, if you know anything about math and algebra, that's going to give us kind of a slope. So that'll give us a smooth, quicker deacceleration than what we currently have built into the physics engine. And then rigidbody.velocity.z divide equals by walk deacceleration. So we can change walk deacceleration to a higher number if we want to slow down faster, or a smaller number if we still want a little bit of that slippery movement going on. So both those lines are pretty much the same, just for X and Z. And that's really all there is to it. We should just put these couple lines of code in, and that'll make our player not feel like they're running on ice. So let's head over to the computer and see what it looks like inside of Unity. Alright, here we are inside of Unity, and let me show you a big problem we have going on with the game right now. You may have noticed, whenever you start running and then let go, it is very slippery. It's like we're running on ice. And you've probably noticed me the last episode I was having trouble. I was trying to line myself up under one of these blocks so I could act like Mario and hit my head against it, which is very difficult and slow going when things are this slippery. So let's put that code into place and fix that. So player capsule, player movement script. So we need one variable. I'm going to put it under walk acceleration, and that variable is walk deacceleration. Float, and I'm going to also make it 5. Why not? I can change it later. Alright, and then we need to put, why don't we keep things organized? and put it down here. So we have basically if we are not pressing W, A, S, and D, so if input dot get axis, or let's capitalize, horizontal equals 0, and I'm going to be lazy and copy and paste this and change this to vertical. So if those two equals 0, oops, I gotta create some brackets. Rigid body dot velocity dot x divide equals walk d acceleration, and copy and paste, but I want this to be z, and I need to put in my closing bracket. So let's give that a shot. So the game should behave exactly the same way as long as we are holding either W, A, S, or D. But as soon as we let go, it looks like we made the number a little too big because it's kind of like stopping really, really fast. So let's tone it down just a little bit. Walk the acceleration, I don't know, somewhere around 2. Let's see what that does. I need to make my player capsule less high up in the air. It's still a little too much. Let's change it down to 1.1. We can't go below 1, otherwise that's going to make it accelerate. Because if you divide by a number smaller than 1, mathematically it makes numbers bigger. So we'll just see how close we need to get to 1. That's looking a lot better. That's kind of like screech, stop. Okay. I'm going to change it just a tiny bit smaller. Where's my variable? 0.05. Because we can only like keep on getting closer and closer to 1. So slow down. You know what? I just thought of something that is a very critical error. Right now, whoops, wrong window. Right now, the way we have this set up, it's dependent upon the computer's frame rate because we didn't use Time.deltaTime. Okay, so this is kind of embarrassing. I actually forgot to use Time.deltaTime in my code, and that's really critical. So, as you can see, you can walk around, and it slows down pretty realistically, and it feels good. But that's because my computer is going at a fairly steady frame rate, as you can see. But what happens if my computer starts chugging, or if I was going on a slow computer, or the frame rate just starts changing? Things are not going to be consistent. So we need to use Time.deltaTime. But for this equation, Time.deltaTime is not actually going to work because it's going to make it a number smaller than 1, and then when you divide a number smaller than 1, it's going to make that number bigger. So that's not going to work. So let's come up with a whole new approach, and let's use smooth damp to smooth this out. So keep in mind, I'm making this code up as I go. So let's add hide in inspector, and let's not hide flags, hide in inspector, and variable walk deceleration vol x float, and we don't need to define it because I'm just creating the velocity variables that we're going to need for smooth damp. Alright, and let's just get rid of these 2 lines of code. So rigid body dot velocity dot x equals mathf dot smooth damp, and we have our current, which is rigid body dot velocity dot x. and our target is 0, and our velocity is walk deceleration velocity x, and the amount of time that we want it to take to reach 0, and we can just use the walk deceleration variable that we already have defined. Okay, and let's copy and paste that for the z-axis. So this is, I mean, we've already used smooth damp a couple times, so you guys should know how smooth damp works. We've used it for the mouse look script, and basically we save the velocity, or we create a velocity variable, and the function smooth damp uses that variable to create a smooth movement. So now that we have that in place, let's just give it a go and see if it is working. So we're running. That works pretty good. That works better than I thought it would. So we might need to do a little bit of adjustments. So this should be the approximate number of seconds it's going to take us to reach a speed of 0 once we let go of W, A, and D. So 0.5 seconds and we stop running. That's pretty smooth, and it's not dependent upon our frame rate. So that means if the computer starts chugging and our frame rate lowers or speeds up, it should still behave the same way. So this whole tutorial is just kind of a mess, but I think we saved ourselves here with the smooth damp. I love smooth damp. It's a great function that is added in Unity, and you can use it in so many different ways. So yeah, it seems like things are actually working now. Glad to get that out of the way. So just remember, the way I had it set up, things just the way I had it divided by walk deceleration, that was dependent on the frame rate, and we want it to be dependent upon real time. So we're using smooth damp in this case now. So I guess this tutorial is kind of messed up now, but at least this line of code is the same. This variable is the same, but we added these two variables and these two lines of code. But for the most part, it's the same general concept. It's just when W, A, and D are not being pressed, slow it down to a speed of 0 gradually instead of having it run around and feel like it's on ice. I guess the next thing we're going to do is how about air control? Because as you can see, we're in the air and you have a perfect amount of control, and when I let go, see, I'm going forward and it slows down to 0. That's not realistic because if I'm not touching anything, I'm going to, keep on going. So we're going to, actually, you know what? Fuck it. I will add it in this exact same tutorial because I am pretty sure it's only one little thing I need to add. So if equals 0 and grounded. So if we are grounded and not touching WASD, we are going to slow down. So here we are slowing down normally, and let's jump in the air, let go of WSAD, and we're still flying normally, and then we slow down. So there we go. I didn't need to add an entire tutorial just for that. That'd be an entire tutorial just for like one little thing. But just look how much better this game already looks. I mean, instead of feeling like we're on ice, we slow down pretty realistically, and when we're in the air, we're flying and hit the ground and then slow down. So now we have a simulated friction system, or simulated feet working the way humans' feet do. So yeah, hopefully you guys enjoyed this tutorial and enjoyed the fact that I just started making this up as I went to kind of fix a problem that I saw. And I don't feel like refilming anything, so I'm just going to keep it all the way it is. So hopefully the next episode I plan ahead a little bit better. And until next time, I'll see you guys later. Keep making games. Okay, I want to change one more thing before I actually sign out that has to do with that Time.deltaTime thing. As you can see right here in this line here, which basically is adding the WASD with walk acceleration, but right now this whole line is dependent on the frame rate, so let's fix that. And we're just going to multiply it by Time.deltaTime. Alright. And of course we're going to have to increase our walk acceleration variable, because right now it's probably going to accelerate very, very slowly, if at all. So let's change that to like 500 and see if it works. It is working, but it's really, really slow, so let's change that to 2000. Well, that's a little fast, but at least it's realistic. Alright, so now our game is working and it's not dependent on the frame rate. So, lesson learned. Keep an eye on the time.deltaTime and whether or not variables are dependent on the frame rate. So, as you can see, games can work when they're dependent on the frame rate, but they typically work better when they're dependent on real time, and then you don't have to worry so much about the frame rate changing. So, yeah, until I see you guys next episode, keep making games, don't make mistakes with time.deltaTime like I've been doing this entire episode. Take it easy. I will see you guys later.